Alright, so here we're looking at using the vertex, the axis of symmetry, and the y-intercept to graph these functions. Now once again, we're not sure what they're going to look like. Okay, so we have to deduce all that information from here. And so again, we're going to be looking at the information in this green box here. Okay, so a good way to look at it is say, well, what form does this function have? It's got x take 1 squared and then plus 3. So it's very similar to this one here, where a is just 1 out the front, 1 times x take h, and in this circumstance h is 1 as well, and our k value is plus 3. So this graph, this box tells us lots of information about it. We have the axis of symmetry occurring at x equals h. Okay, in our circumstance it's 1, and the vertex is at h comma k. Alright, now it's exactly the same as this one here that I'm circling with my mouse right now. The only difference is we've got this plus k on the end. Okay, and if we remember from translations, this just affects how far up or down the graph's going to be. Okay, so it's the same as the function touching the x-axis, only this time it's got a vertical translation of k units. Alright, so in our circumstance, it's touching the x-axis at x equals 1, and it's been translated vertically 3 units. Alright, so we have axis of symmetry at x equals h and the vertex at h comma k. So in this circumstance, the vertex, or the minimum point, occurs at x is 1 and y is 3. Okay, so when x is 1, y is 3. Okay, so that's the minimum point. The next thing we need to know is the y-intercept. Now the y-intercept occurs when x equals 0. So we just need to put x equals 0. Okay, so when x is 0 here, that's the y-intercept. So if we put x is 0 into this equation, we have 0 take 1 squared plus 3. And of course, 0 take 1 is just minus 1. Minus 1 squared is positive 1. So we have 1 plus 3, which is 4. So when x is 0, y is equal to 4. The y-intercept is 4. So we have our minimum point. And we also know that the axis of symmetry is occurring at this point h, okay, when x is equal to 1. So we have the axis of symmetry here, which means the function is symmetric about this point, and that this is the bottom point, and that it passes through that point. So the function is going to look like this, just as a rough sketch, okay? And you can check that using your calculator just by graphing this and finding what the minimum point will be. Okay, if we look at the second circumstance, all right, again, it's very similar to the one we just dealt with, okay? It's got x plus 2. Now, the general form that we have here is x take h units, okay? So if we've got x take h units, and this becomes plus 2. So what we have then is x take away minus h, which would become x plus h. So really what we've got in here is h is equal to minus 2. Okay, not positive 2, minus 2. So a good way of looking at it is whenever we have a positive, like we do in this circumstance, it's going to be the negative of this number. Alright, so if we have our h is minus 2, so once again the vertex of this function is going to occur at x is minus 2 and y is k. Now k in this circumstance is this 1 here. So the vertex occurs at minus 2 and 1. Of course, the axis of symmetry, AOS, occurs when x equals, again, minus 2. And the y-intercept occurs when x equals 0. So if we put x equals 0 into this equation, we have 2. When x equals 0, we have 2 times 0 plus 2 squared plus 1. Okay, and now we have to calculate the squared first. So we've got 2 times 2 squared plus 1. 2 squared is 4. So we have 2 times 4 plus 1, and 2 times 4 is 8, plus 1 is 9. So the y-intercept is 9. So here we have a function that has a y-intercept of 9. Okay, it has a vertex, or the lowest point, the turning point, at -2 and 1. When x is -2, y is 1. Alright, so if we go across -2 units here, -2 and up 1. Okay, this is the lowest point. And the axis of symmetry also occurs at x equals -2. So axis of symmetry we just demonstrate with a dotted line. So it's going to look something like this going through those points. Okay, again the axis of symmetry just tells us that the function is symmetric about that line there. So that's how we solve these problems. It's just about determining which one of these lines up with the function we're dealing with, and then using this information here that we're given.